All right. So, Yashwant, can I make you the organizer, or Midli, or Mamta, or Abhay? Okay. All right. All right. Then let's start. So, have you started the recording, Yashwant? Great. Great. All right. So, should we start now with our Hive discussion? Or there was one thing that somebody was asking yesterday regarding the. Okay, so there are two things that we can discuss today. One was, all right. So one is this one. Okay, so let me just start recording. Okay, all right. So there is some issue which Abhay is facing with respect to tweets.csv. Is that okay that we can take a look? All right. Okay. Okay. No worries, Yashwant. Okay. I think this will help others also. So, all right. So, Abhay, will that be all right if I make you the presenter for some time? Let's take a look. Okay. Okay. All right. So I'm making Abhay presenter, and let me take a look at the problem is he facing while uploading the tweets.csv file. Okay. All right. So he's clicked on. All right. It says error undefined. Strange. Strange. Okay. Okay. Let me try to upload in my folder. For others, it's working, right? Okay. So Biswa is saying that he was, for others, it was possible. So what would I do is I'll try to log in into Abhay's account and then try to upload it. So did you try any other browser? In both the cases, you're facing that same problem. So what will I do, Abhay, is okay, I'll try to log in into your account and then see. All right, that might require a little bit of time. So looks like everybody else is able to do. In the meantime, could you go to slash data folder, slash data, and then you could go to, not inside that, pig. Oh, it's not there. Okay, go up, go up. So I think what will I do is I'll upload a copy of tweets.csv into slash data slash pig. Okay, so I think one is that. Second is okay. Let me. Okay, so after this class or maybe tomorrow, I'll just go through. Okay, login into Abha's account and check here. Okay, and yeah, also upload the. All right, that's pretty much. So, all right, I understand what needs to be done. Abhina, let me try to do it after this class. Okay, all right, all right. So, whatever data. Yeah. So yeah, you don't have permission to write into slash data slash pig. That's why I'll do it on your behalf. I'll do it for all of you so that you can directly read data from twitch.csv and do not have to worry about copying the data. But nevertheless, the uploading of data should always work. And I need to understand, is it your firewall issues? Is it some other issues which is obstructing the upload of file? Okay, so that I need to check. Okay, maybe we'll do yes, that's right, Prisva. You don't have right permission to slash data slash pig, so you can always upload the data into your home folder and then start using from there that location in the HDFS. All right, and jar needs to be local. So as a thumb rule, whether it's MapReduce or whether it's Pig, the code needs to be in the local folder, while the data has to be in the HDFS. All right, good. All right. The other thing, there was one more thing we wanted to discuss. Okay. All right. Yeah, you can take the time. All right. Any other questions before we start? How does Grunt know that how does Grunt knows to look at local jar file? Because the normal behavior or the common behavior is the default behavior is to look for jar in the local folder. Okay, so that's how it has been designed. So it generally looks it basically looks at the absolute location when you're registering a file. All right. All right. There was one more thing that is pending a little discussion, and it is related to our question on this one. Okay. Biswa's last question. Okay, okay. So yes, Biswa, I did take a look at your assignment partly, and it looks good to me. At least first three questions looked good to me, and we will evaluate those quickly. Okay, is that what you wanted to ask? All right. So okay, okay. So the question you had yesterday was, yeah. So you mean regarding this discussion? All right, all right. Let me just take a look at even this one. All right, let me just take it for today. All right. So his question was, as per the initial discussion, Hive does not allow insert, update, delete for the data, but you said we can add columns to the table. How is that possible without updating the data? Okay. So mm, the way it works is, okay. So let me try to make it clear. Let me try to make it clear that, so what exactly happens in Hive? Okay. So the way Hive behaves is it provides you a way to look at the data. Okay. So you already have a data. You already have the data in the file system. Okay. You already have stored somewhere. Okay. So and you want to take a look at this data in a structured manner. Okay. So you go through Hive. Hive make it possible to make it look like a tabular data. And how does Hive make it look like a tabular data by by the use of tables. Okay, you create a table in Hive, and you also tell that, hey, this is how my input data is structured, meaning my rows, my text is split by lines, and my cells are split by tab. Okay. Okay, so basically you tell Hive that first take the full text, split it by new lines, then next thing you should do is split each line by tab and give me, and that's how you can prepare the table and give me the table. So every time we do select a star from a table, internally Hive will be reading the data via via Hadoop MapReduce and will be doing the work for you. So essentially, Hive is providing you a window through which you can look at your data in in a way that is nice, in a way that is structured. Okay, so Hive is that kind of, you can think of kind of uh, a way to look at the data. Okay, it did not it did not provide modification functionality, but in the new update they call it Stinger update. That one is allowing Hive to modify the records as well. Okay, but for today's discussion, we will, or for this purpose of this class, we will keep Hive as purely an analytics engine or analytics tool. Okay, now since Hive can provide, so what is it that you define? What is it that you tell Hive? You tell Hive that, hey, my table is having these three columns. Okay, these three columns, and how do you prepare this column? By splitting data by tab, or by splitting data by column, commas. Okay, so that way you can tell Hive how to split the data. Okay, next is that so every time you talk to Hive, Hive internally would talk to the file system via MapReduce. Every time you say select start from this, internally it's going to execute a MapReduce and give you the results. All right. Now that means that Hive has nothing to do with modification of data in the version which we are focused right now, and that's how it's supposed to be. So whether today we realize that we were focused only on first three columns, so we were just ignoring the rest of the columns, and later point of time we realize that we can have more columns read from the data file, so we don't ignore rest of the columns, and we are having we are reading remaining columns as well. Now the other things you could do at later point of time is you could change the data type of the of the various columns. And if you change the data type, then while querying this table, it will try to fit the data or parse the data from the raw text into the Hive table. So whatever schema you give, it'll try to fit it in. If it finds that it can't fit in, then it'll give error, or it'll fill the columns with null. Okay, fill the columns with null, as in whatever result you get, it'll say that second column does not have any value. Okay, so that's how it is. Okay, Mahesh's question is, when I add new columns to the data, do I have to delete data from table and load it again? Not really. Okay, so adding new columns to the data table. Okay, so adding new columns to a table means that, hey, now I want more columns from this data. Okay, so if you just change the table schema, now Hive will try to read the file and try to present the file in that tabular format whatever you have created. Okay, so you have to understand what kind of data format you have, and only according to that you can prepare the table schema. Okay, if your data is having only two columns, if your data is having only two columns and those columns are separated by colon, okay, then you will have to define your table accordingly. So that's how it is. You first have to understand what kind of format you have in the data, and accordingly you define the table. Okay, because you cannot define your table structure arbitrarily. Okay, so you do not modify the data at all. Instead, you define the table according to the actual data format. How many columns it has, what kind of data type it has, and How are my column values splitted? And how are my rows separated in the data? Yes. So yeah, that's correct, Biswa. It is basically a logical view of physical or raw data. All right. Do I make sense to you? All right. All right. So have has anybody attempted this problem so far? So yesterday, somebody was asking me to discuss this problem. Okay. So let's have a 10-minute discussion and then we will move on. Okay. It's very important to get your doubts clear. Okay. All right, Mahesh, and everyone. Okay. All right. So the problem which was a pending discussion is based on the content of a very large text archive. So I'll take a step back and try to explain what the problem is. So when you type a message in using your phone, it starts quickly giving the suggestions. It starts quickly giving the suggestions what next word to type. So how does it know which suggestions to give? So generally, this is based on historical data and understanding of historical data along with your information. Okay, so a big so is based on the general behavior of people first, and then a little bit custom for you. Okay, so the way it is done is the whole text archive. The way it is done is that you gather a lot of text from public sources and try to understand the language. Okay, which word people use most frequently after which word. Okay, so one of such sources is Wikipedia. So you can download the data from Wikipedia and try to analyze the text. You could pick up the words from the text and then analyze which word occurs after which word more frequently. If you have 20 words, if you have 20 words following one word, you figure out which word is most frequently occurring, and you just show the top 5 recommendations. Okay, here we are talking about top 3 or top 5. Okay, all right. So there are many ways to solve this problem as well. But but again, if you try to solve this problem in using a single node, it might not be that easy. So the Wikipedia's data is fairly big. So if you don't have a MapReduce pipeline, it might overflow a single node or a single computer. Therefore, so if you imagine that if you have to do it by yourself without using Hadoop, what will you do is you'll prepare a big hash table. Okay, you'll prepare a big hash table, and in that hash table you will put first word, second word, then again the next key you will add is second word and third word, and so on, right? And then you count which word comes after which word most frequently. All right. So everybody, so has anybody tried to solve this problem? Okay, Yashwant has tried. Who else? All right, all right. So let's take a look at the common approach. Okay, so we would basically break down each line of text into pairs of word. Okay, each line of text you would break down into pairs of text. And once you have broken it down into pairs of text, okay, you will be able to group by you'll be able to group by key, and all the words will come together, and from there you can do the frequency analysis. All right, you could do the frequency analysis afterwards. All right, is this clear? So for example, to find out which are the words that follow how, a best way would be to make how as the key, and all the words that follow how will be the value. So, and then when MapReduce groups them together, so what will happen is all the words that follow how will come together, all the words that follow are would come together, and all the words that follow Ram will come together. Okay? Now, the problems with this kind of model is, okay, so can anybody, all right, so you have these key values, okay, and you have converted it into a kind of something which would, if grouped correctly, it'll bring all the words that follow a particular word together. For example, all the words that follow happy will come together, all the words that follow to will come together, all the words that follow you will come together. Okay? All right. So, yes, there are two problems which Mahesh and Yashwant has mentioned. One problem is with this piece of code that Ram and Happy should not occur together. Ram and Happy should not be occurring together. Okay. Any other suggestions? Yeah. So do you see? So do you understand this approach? Um, how did we? How will this work? And if so, then do you see any problems with this approach? Any other problems, Mahesh and Biswa? So there are two problems identified so far. One problem is one problem is that these two words should not be grouped together because these are not technically these two words are part of two different sentences. So it, this does not mean that if somebody has typed Ram, he would have to type happy. Okay. because these are two different sentences. It does not make much sense to have this kind of a situation. Okay. Second is that just because line has ended here, it did not stuff the more text into line. Therefore, these two words are not paired. Okay. Ideally, it should have had you. It should have had here you and happy, you and Ram. But why it did not happen? Because these are in two different lines, and the way the default behavior of MapReduce to handle text is the only single line is available to your mapper at a time. Therefore, only your mapper code is functioning only on this. Therefore, it could not pair this and this. So, first mapper code converted this into key value. Second mapper, when map function, second map function converted this into key value, and third map function converted this into key value. Okay. All right. So Yashwant's suggestion is that you need to read the data in paragraph. Okay? You need to do read the data in paragraphs. So how would you do? How would you read the data in paragraphs? Anyone? Instead of a single line being fed to the map function, we should be feeding paragraph. Okay? Good. Very good. So you could read. Okay, so you could use a input format delimiter as double slash n. Okay, so instead use a regex delimiter. Okay, there is a delimiter format. Okay, you can use that one. Okay, good, brilliant. So if we can break down this file into paragraphs and we feed full paragraph to our map function instead of a line at a time, then these problems won't be there. And while processing paragraph, you can detect whether the data contains dot and split that by sentences. Okay, that you can parse it. So you can parse each paragraph and figure out the key values that should go together. All right, is everybody with me till here? Abhay is saying that by judging tab character, okay, okay, okay. Hmm, I need to understand this part, Abhay. So he's suggesting that by judging tab character, we could, okay, we could handle this. Okay. Mahesh is suggesting that should we use input split of a sentence? That could be also a good idea. That could be also a good idea. But he may so maybe we could use dot as a separator, but then dot might occur in this, or it might occur inside double quotes. Okay, double quotes as in like this. Okay, and so on. But that also would do a good job. Yes. Okay. Midli's question is there a way to solve it in pig or hive? Yes. Yeah. And Yashwant's suggestion is that if we have input split as a sentence, it will result in a lot of mappers. Yes, that's right. Okay, and Midili's suggestion is, question is, can we do this using pig or hive without having or we have to go with MR? Okay, yes, you can do in this in pig or hive. Again, in pig also you have to use the way we are using the what do you call um, splitter. So you will have to use regex splitter in pig too. Okay, just that while loading the data, you have to separate the records by /n/n, and then you could further split the data, and then you will have to iterate. You'll have to do a for each. You'll have to do a for each and generate first and second. Okay, so it's going to be tough with pig because you will have to use loops and you will have to use conditions. So it would be difficult for pig. Okay, picking up two words like this are going to be a little tricky in pig, but can be possible. All right. Similarly, in case of hive, because we are iterating over a record. So when you iterate over the values of a record, generally hive and pig do not do a great job. All right. Do you see any other problem in this solution? Yeah. So Biswa's question is, okay, why splitting the input into sentences would require more number of mappers? So it would require more number of map functions. It would have more number of map functions. I mean, execution total number of execution of more number of functions would be higher because there'll be more sentences. So in this case, if we are executing it for per sentence, the total number of map function is going to be more. Okay, that's the only difference, but that's insignificant largely. The bigger problem I see is these sentences. If you are handling paragraph by paragraph, you can do a little bit of a grammar parsing. Okay, while splitting based on the dot, you may not be in a situation to do the grammar parsing because you have already splitted the data into a very small sections. Okay, all right. So the other problems which I foresee in this approach is the computation of frequency should be handled correctly, or computation of frequency can be further can be made faster. Okay, because what's happening is if you think about the words like R, right? Words like R will have millions of words following them because these are very common words. These are very common words, and there'll be millions of values for such keys. And when millions of values would go to a single reducer, they will overflow the reducer's memory. Okay? Or you can look at it this way, that if you try to compute the frequency of values, so for each key you have to find out what are the top 5 or top 3 most valuable mostly occurring words, right? For that you might have to maintain um, hash map. Okay, you might have to maintain a hash map. Okay, and if you try to maintain a hash map of top 5 values, it's going to take a lot of time. It's going to take a lot of time, and therefore it makes more sense to have the values sorted as well. Okay, you can have the values sorted as well. Okay, so the idea of custom sort, what do you call, custom sort comparator and custom grouping comparator comes into play. Okay, so I want to show you a simple code whereby whereby we can we can uh, you know create our custom keys, custom sorting comparator, and custom grouping comparator. Okay, so okay, let me describe it again if I missed if I could not convey. So here if you see the values, if the values are, if the all the values for, let's say, word like R, if you have to sort all the values and find out which word is having which word is having what uh, which word is having highest frequency after R, then it's going to consume a lot of memory because you have to load that data into the memory and try to sort it. So that's not a great idea. Why don't we use Hadoop itself to sort values as well as the key in this case? Okay, so how can we use Hadoop to sort values along with the keys? Okay, that's where the custom grouping and custom sorting comes into play. So what we could do is, while sorting these while sorting our records using Hadoop, we could tell that, hey, sort our records based on these particular values and group our data based on these particular values. So that's what MapReduce does. Okay, so I'll show you. All right. So So Maisie's question is, what do you mean by reducer doing frequency analysis? It just brings all the values together. So if you think about how would it happen is, okay, so let me try to, okay. So imagine that if I had some data, right? Okay. So let's say we there are key and values, okay? All right. All right, let me try to make it. Okay, so the way it would happen is, imagine this. There are a million words following R. Okay, so reducer, let me try to write a pseudocode. So we'll get the first word, okay, as one argument. Okay, and second argument will be list of all words following first word. Okay, so that will be the list of second variable will contain list of all words following second first word, right? So in case of words like R, there'll be millions of words that follow it. Now this reducer function, what it will have to go through is find top 5 most occurring words out of this, okay, out of list of values. Okay, and how would it do is it'll prepare, let's say there could be multiple things. One could be sort, and okay, sort by frequency, sort the word, sort the words lexically, lexically as in the way it's stored in dictionary, and sort the words, and then find counts, then again sort by counts, okay, or scan through counts, scan through counts, retaining only top 5. Okay, is this approach clear to you, Mahesh? Reducer will get a list of all the values or all the words that follow the first word, right? That's how we have formed our key value. Because our key is the first word and value is the second word. And we have done for all the possible pairs in this text. So while mapper is giving first word, second word, all possible pairs in this text, all possible pairs as in all possible adjacent pairs. Okay, so and Hadoop will bring key and values together. Now, in the reduce function, okay, in the reduce function, you can find topmost occurring from. You will have to find top 5 most occurring words from the list of words. Okay, and okay, and return only top 5 list. Okay, or you can say the code will look like something like first word, return first word, comma, top 5. Okay, I'll say list of top 5 most frequent words. Okay, this is how it'll look. Or if you're talking about, let's say, typical context dot write. Yes, that's right. Did it make sense to you, everyone? Okay. All right. So only Mahesh is with me, Mamta, Mithili, and Biswa, and Yashwant, and Abhay. All right. So while mapper is just giving first word, second word, and then second word becomes first word, and third word becomes the value, and so on. So it goes through the full list of words. Okay, spitting out one, how are you, and then you Ram, and then Ram happy, and so on, whatever way you are planning. Okay, so it'll keep on printing all the possible pairs. All right, so this way you will get. Now here, if you see, this is going to be the most CPU intensive task. If imagine every reducer has to do this, then what is the benefit of, what is the big benefit of having Hadoop? Can't we can't we delegate this work to Hadoop itself? Okay, this is where the sorting comparator comes into play. Okay, what does Hadoop provide you is So far what we have studied is that grouping and sorting happens on same criteria. Okay, that is something which we have studied so far. So I want to make it little bit more. I want to mm, mm, I mean put more. I want to make it clear that in Hadoop it is possible to have grouping and sorting criteria as different. You can group on you can group on first key and so on, while you can sort on more than first key. Okay, I'd like to show you this part. So is that so far whatever we have discussed, we have talked about a situation where sorting happened on the same key as well as grouping is happening on the same key. Okay, but in this case, in the case which we have on hand, we want to we want to group it on first word. Okay, okay, and the word for which we are seeking the suggestion, we want to group it, but we want to sort the whole data first by first word, then 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 by second word. Okay, okay. So what do we want to do is we want to sort this whole data, not date. We want to sort the whole data based on this criteria. While we want to group it on first word, we want this. Okay, we want first word and list of all the words after this, but we want this part to be done by Hadoop itself. We want Hadoop to order the words for us. Okay, yes, we will share the MR code with you. All right, all right. So basically you could group it on first word and then sort the whole data on first word and second word. And I mean, the way it happens is you first of all, so the steps involved are you first define custom writable. Okay, the way we have int writable, long writable, and text. Similarly, you can create your own object and then define sort comparator, and then we define the what was that grouping comparator. Okay, and that's it. Now, in basically in sorting, we tell that, hey, order my data by these fields, and grouping, we tell that please group my data by these fields. All right. It's like having a select query saying select star from my table, group by this column, and then having another clause for order by. Okay, that's right, Mahesh. Hadoop by default sorts the mapper's data before giving it to reducer. That's correct. But only, okay, but by default only on key. That's the by default behavior. We can change that behavior by providing sort comparator hook and grouping comparator hook. Okay, All right. Question from Abhay is, can we talk about Mapper a little bit? Yes. So Mapper will do the way almost like this, except that it will take care of the boundary conditions. Okay, boundary conditions as when it will operate sentence by sentence or paragraph by paragraph instead of instead of the instead of line by line. All right. All right. So I would like to show you some custom code, and I will send it across as well. Okay. So yeah. So Yashwant had done some work. I'd like to show that one. Okay. All right. So I'm making Yashwant presenter for some time. All right. And then he'll just go through his code, and I'll tell what is where, and that will give you a good example of this particular thing. And later on, I'll also share the code with you. All right. So I'm making Yashwant presenter. Is that okay, Yashwant? All right. So whatever we are talking about, having defining writable, defining sort comparator, defining a grouping comparator, so I like to show it in Eclipse of Yashwant. All right. So Yashwant has done a good job of. All right. So here you can see that these are the main classes which he has created. So first of all, show us the writable, the main writable. Yeah. So what he has done is he has first defined a class called two words, which is comparable as well as writable. What does it mean by writable? So as we discussed earlier, why did Hadoop create the custom classes like text, int writable, long writable, so that marshalling these objects into the bytes is very easy and very efficient. Therefore, in the similar manner, the way Hadoop has done for the primitive types, you also have to sometimes customize the behavior by writing your own writable. So all you have to do is whatever class object you have, it's like a composite class you're creating. Instead of having the primitive class, you're creating your own class for the definition of the key or for the definition of a record. It's a record that you are trying to define here. And so you basically implement a interface called writable comparator, and when you do that, you have to implement two parts. First is called read fields. Given a data input stream, how would you convert a data input stream into the object? So here what he has done is he has read two fields called in.read and in dot uh, okay. So basically right now he is assuming that his data is already formatted in the key value pair. Okay, so the mapper task is not exactly the problem statement, but here what his assumption is, the data is already in two columns. Okay, so that part we can take separately, but the objective, which is to first understand the customization of writable behavior, it's actually good for us. Okay, so he has read two fields called first word, second word from the input, and similarly you will have to implement something called write, okay, which will write the data, write this object into the stream. You can see that the part which is selected. So you're saying that write this data into the stream. Okay, so this is another part. Now the next thing you have to implement is the the comparator part. Okay, so these are the constructors which you may define or you may not define. Okay, toString is also something not very much needed. What you need to define is, maybe you can do you can give out primary key and secondary key by get pk and get sk, and so on. If you go down, yeah, here this function called compare to is this function called compare to defines this compare to function defines how are these objects compared with each other. So what he has done here is compare the first word with the first word of the second, the another record, and then second word with second word, which means if two records of this particular object, two instances of this particular class are compared, you always get an order. Okay, so compare to gives that. Okay, you can see that first it compares the first word and second word, and in case the result is zero, only then he compares the second word. So you will have to implement uh, compare to object. Now can you show me the grouping comparator? Yeah, so in here, now he has defined something called grouping comparator. Okay, so once you have defined your class, which clearly tells that what are the variables in that class. Similarly, that class clearly tells that how to convert data from input stream and how to write data, as well as that class also tells how to compare itself with somebody else. Okay, now the second part is the grouping comparator, that is done by extending the writable comparator. Okay. Now in here also you can define your okay. So here the most important part to notice is that here we are only comparing the primary keys. Okay, we are not comparing the second word. Why? Because we want to group the data only based on the first key or first word. Therefore, we're comparing only on the primary key. But if you go into the sorting comparator, the second one, okay, here you can see that. So this in here we are comparing the both ones, the primary key as well as the secondary key. You can see that if first he's comparing the primary key to the second word's primary key, and then meaning he's comparing first the first words of both the records, and then in case both are same, meaning if the result is zero, then he's comparing the second one. So the sorting is happening on both the words, while grouping is happening only on one word. Okay, so that is something uh, which is different here in this example. All right, and now once you have done with writing both the comparators, you can go to the driver, and there you can say sort by this, group by this. Okay, you can see the driver here. You can see here we are saying job.set grouping comparator, job.set sort by comparator. Okay, that's it. And here you can also define what is your key class name. So here we are using two words class name. That's it. And rest of the process is exactly same. So that's pretty much with respect to this. There is one more part which I'm missing here, is the partitioner. Okay, so when you are defining your custom key, do not forget to implement hash code function, because hash code will determine which keys would go to the same reducer. Okay, if you have multiple reducer, if you have one reducer, you're happy. But if you have multiple reducer, you have to implement hash code method inside your writable class, the custom object. The way we have defined here two words class, where we first define how to read data, how to write data, then we define how to compare one record with another. Comparison is still forgivable if you are providing a sorting and grouping comparator. Compare to is still, you can keep it to the back seat, but you have to provide a partitioner if there are multiple reducers, because that partitioner will decide how to convert your object into a num. So first you have to define a hash code. That hash code will determine how to convert your object into a number. And once you have defined how to convert your object into a number, then based on this number, by doing a modulo, by computing the remainder, it will take your key to a particular reducer, because in case you have multiple reducer, some keys go to one reducer, some keys go to another. Okay, so you have to make sure that one key does not go to two different reducers by defining your hash code method correctly, by providing system that, hey, I know how to convert this object into a number. All right, that's pretty much. All right. So let me see if we have any questions. Good. Thank you, Yashwant. All right. Yes, you want to say something? Okay. The operation is correct, but not all keys are sorted. Okay. Okay. So he's saying that although the output is correct, but not all keys are sorted. Okay. All right. One more thing, always have the JUnit test case. Same thing, the partitioner, whatever we have here for the actual reducer, for the same thing could be done in the JUnit test case. Okay. All right. So, yeah. Okay. So what he's trying to display is primary key is z, and then okay. Okay. So what I see is not really, not really. Actually, it's alphabetically there, right? So the smaller case is bigger than the uppercase. Okay, the ASCII value of lowercase is bigger than the ASCII value of the uppercase. Okay, so this order is correct. You can see that ABC, and Z. All right, all right. Nothing to worry on this. Good, good. All right, everybody with me? So I was just going through one example what Yashwant has done. He's done a very good job of going through the example, and yeah, thank you, Yashwant. Right? Do you have any questions, or should I shift to my screen? Or if you have any questions, you can ask now. Okay, great, great, Yashwant. All right, and yeah. So, do you have any questions with respect to this code, or should we switch to my screen? You want to take a look at some more thing, or what we'll do is we'll just send you this piece of code, and that'll be easier for you. And also, I'll also fix a couple of things in this code. So, okay, Yashwant, just send me this piece of code. I'll make it corrected, and then we'll share it with everybody. Good job, great. All right, all right. Thank you, Yashwant. All right. So, yeah. So that was a little more digression because this is something, the sort by comparator is not something which we have covered earlier in the session, but I think I'll be including it in future. All right. Our every class, every subsequent class is bigger than the previous one because we have been including more exhaustive, as in when more features are becoming prominent of any component, we are including that and keeping it updated instead of only following the certification exam. We are trying to keep it more exhaustive. All right. All right. Any questions at this point for me? And don't worry about number of classes. We can always manage it. Okay. We can always extend it. ये बिस्वा महेश मितली ममता Abhay Yashwant. All right, should we go ahead with our Hive discussion? That was a recap and more of Java coding into MapReduce. Okay, the most important thing we learned was that it is possible to group by a certain criteria while sort by certain other criteria. Okay, so Mamta is saying that it's difficult for me to understand Java code, but good news is that same thing could be easily done with Hadoop streaming. Okay, you could try Hadoop streaming. Let me just go through their library. So you can see that they also have the same mechanism of specifying the comparator class. Okay, you can see it's a key comparator you can specify here. So take a look at this particular example. That should be good enough. Okay. Right. So this particular part, you should have a look at these partitioner and all. If you're more inclined to the comparator. Okay. For that matter, I have exhaustively used this kind of technique with Hadoop streaming, and it works pretty good. It works really well. All right. So you can try that. All right. Brilliant. Good. Now, moving on to our discussion on Hive. All right. So, where were we on Hive earlier? Good. So where were we? Yeah, we were talking about Hive Meta Store yesterday, as well as we talked about this part. All right. So basically, if we create a table, we tell that it's optional. If we tell that this is the location, then that location will be the data will be read from that location. If we don't provide the location, it will create a folder inside warehouse. Okay, and that will be considered as location. And either you upload the data into this table or you directly copy the data into the target location. It is the same thing. Okay, just that this should be correct. We should specify the correct um, way of formatting the input data. Okay, Middle East question is, where are we loading data from Hive into Hive table, from HDFS or local? The answer is both. If you are on the console, if you are on Hive console, you can use the keyword here called local. Okay, you could say load data local. These are the three keywords, and then you say in path, and this is the path. So from this path to this table, basically this table will now have the data in this. Okay, the most important part to understand is, if your data is local, then this data is going to be copied into HDFS. Okay, the data is going to be copied into the location of this table. Okay, in case the data is in HDFS, in case this data for this table is in HDFS, in that case, in that case, the file, this particular file, for example, will be moved to the location of NYSE. And what is the location? Either this one while defining the table, or or the default one under warehouse. Okay, so loading the data involves these many steps. So loads the data from a file. Okay, basically loading the data means copying the data from local folder to the target destination, and destination is derived from the, either you have hard coded it while defining a table, you have mentioned that, hey, this is my location, and every time you load the data goes into that folder. Okay, while please note that the translation is not happening at the time of loading the data. There is no transformation involved from one format to another while loading the data. There's a big misconception when we talk about Hive tables. Whenever we think of loading the data, we feel that this data which we are loading will get converted into some format. Okay, but that's not the scenario. Okay, hive table is basically a kind of a symbolic link, or kind of a view, logical view, as Biswa says, is a logical view over this file. Okay, so that's a most important part to understand, and rest of the things will become simple. Similar to pig, the way we said a equals to load this file with these columns, it did not modify any data. It simply made this a represent that file. Similarly here, when we say create table over this location, it essentially means that this table, whenever you are going to query, I'm going to read that location folder. Okay, and using this delimiter. All right, so that's the probably most important idea. All right, so we have did we try to, yeah, I think yesterday we were able to query this table which we created here, NYSE table, right? So let me also open this Let me open my CloudX lab. All right. His first question is this overwrite mentioned every time? No. Okay. Overwrite basically deletes all other files. So also notice that this location, when we say location, it's going to be a folder. And every time we say load, the data gets copied to this folder. Okay. Now, either we could say overwrite. In that case, all other files which were lying in that folder will be deleted and your file will be moved to this location or copied to this location. Okay. And in case you do not specify overwrite, your file will also be copied into that location with a different name, and you will have multiple files in the same folder, and the data will be essentially concatenated. Every time you query this table, it's going to bring the data from all the files lying in that folder. Okay. So data is either located at the location which you specified or at this position. Okay, let me try to show you. All right. So what was that? We can go to this location, and best way to go to this location is using apps warehouse. So here you can see for every table we create, it has a folder here, and you can go to any folder. Let me go to my own folder. All right. So it doesn't have any data per se, but generally you will have, yeah, so you can see that there are two folders further and so on. Okay, so you can see that further the files are can be located in the folders or at the top level itself. Biswa's question is that means we can append data to the table in Hive. Kind of, yes, but not row-wise operation. It's like full file got copied to the same location. Okay, that was all right. And in the similar way, okay, the similar way we have loaded the data from a file, either the local or HDFS. Okay, in the similar way, we could write the data from a table into either the local file or a directory in HDFS. All right. All right. Any questions at this point? Good. Good. So you could say insert overwrite local directory or insert overwrite normal directory, meaning this is HDFS, this is local, and you could save the data or parts of the data. That is something important. Here I'm saying get me the data from NYSE daily and where symbol is equal to CMC. So we could partially select the data and then save it into this folder. Okay. All right. So, okay, let's take a break for 10 minutes. Back by 8:42 a.m. IST. All right. So should we start now? All right. Okay. Here we go. All right. So, all right. So Hive also comes with the idea of partitions. Okay. Sometimes what happens is that your data is split into multiple files, and you want to differentiate one data from another. Let's say all the data from the day one is in one file, all the data from day two is in another, and so on. Okay. In those cases, partitions are very much required. Right? Or imagine this, that you are maintaining the log file of a server in a folder, and these log files are for different dates. Okay, these log files are for different dates. So what you want to do is you want to combine all of these log files into a single table, and you also want to keep a difference, as in you should be able to say select star from my table where log file is equal to date number one. Okay, that means you are only looking for the data for one of the files. Okay, so basically these partitions do very good job of combining data from multiple files and presenting it at single place. Also 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 whenever we are so whenever we are querying the data and we are specifying a where clause saying give me data for this particular column, only those partitions will be queried which fall into that range. Okay, so essentially partitions avoid the full scan. Okay, we could have done things like we could have concatenated all files into one, but then if we concatenate all files into one, what would happen is the scan will increase. Okay, whenever we need to find a record, we'll have to go through all the records. Okay, so the data is stored in different files based on the various combinations of the columns, and you have to define the partition using partition by clause. Okay, and okay, so partition can happen on multiple columns. You can also add partition later on. All right, I'll show you one example. I think the example will make it clear. The example will make it clear. Let's take this example where you have one file called the amp. Okay, this file contains three columns: Sandeep, Tan, BTech. Okay, basically it contains three columns saying some name, salary, and string. I don't know the data, but I've just put some random data. Okay, so this particular file contains this data. All right. Now imagine that there is another file containing similar data but for another date or for another criteria. All right, I'll show you the two files, or if you want I can create more files. It is already available. Where is my data available? So okay, not this one. Okay. Yashwant's question is RDBMS partition is based on rows and this is by column. Yeah. So you will understand this is in more easier fashion when I give you an example. Okay. Let me log in. Okay. So Hadoop fs minus ls slash data slash hive. Okay, so there are these two files called the amp and the amp1. Okay, let me just copy this to my local folder, or yeah, I'll just copy. We could also have done data and hive. This is one example which I'm taking. Okay, so here are two files. One is the amp. Okay, it contains these three columns. Okay, and then there is the amp1. Okay, it also contains three columns. Right, now what we want to do is, let's say we have two parts of the data, one in one file and second one in another file. What we could do is we could create our table. Okay, let's just create a table called people. All right, and what was the database we were using? We were using December 12 and we were saying SG December 12. Okay, so let's go to Hive. How do we go to Hive? We go to Hue browser and then we go to Hive, query editors and Hive. All right. So, okay, we are already in SG, this one. Okay, now I'm saying create table called people. These are the three columns I have created. And I'm saying there's a fourth column called qualification. Okay, that we will supply by hand. Okay, that will be kind of a hard coded column. Every time we load we specify its value. Okay, so three columns will be coming from there. All right, now let's check if it is created or not. So you can see the people has created. Now what we do is we import our two files, this and that. Okay, let me just modify it a little bit. It was designed for running on the local folder. I'm running it from the HDFS. Now I'm saying load data in path the amp1, and I'm providing a fourth column called qualification equals 1, qualification equals 2. All right. So here we go. So it says that load data from this path into the table called employees with the partition qualification equals 1, and then load data in this path into again same table but different partition. Okay, now we execute. Okay, oh, it says table not found because it doesn't exist because we have named it people. Okay, and yes, what does it say? The path called the amp is not matching. So instead, we'll have to provide most likely the user slash what is my folder name? This is my login name. So here is my login name. Oh, this is some other ID. It says Sandeep Giri 8332. Oh, it's some other experimental ID I was creating. Alright, so this is the one. Good. Alright, so it has done the job. Let's try to see if it has done the job. Select star from people. You can see it has got 4 columns. 3 columns from what we had designed called name, salary, and degree. Fourth column which we had hard coded. Okay, so in case you want to see again, this is what we did. We said load this table into people, add one more column called qualification equals to 2 with this value as 2 and qualification is the name of the column. And here we are saying load this where into the table people with this partition. All right, sounds good to you? All right. Which was saying technically a partition can be divided data of a single file. It's actually when we are loading data, we're loading from multiple files. Okay, technically, yes, the definition of partition is we slice the data into parts and put it at different places. Okay, but here the partitions definition is other way around. You have a lot of partitions, you want to combine them together and represent it as a single unified data set. Okay, this is very important to have this kind of structure so that you will be able to query from disparate sources or multiple sources of the data. All right. So Bidli's question is, can we partition with an existing column? No. All right. You have to have partition column like this. We have already defined qualification column. If we try to say partition it based on say name, that won't be possible. Okay. Yeshwant's question is, but very good set of questions. Partition is only at the time of load. In RDBMS, partition would be specified at the time of table creation. Okay. And whenever rows are inserted, they are stored in respective partition. That's right. But here it's at the time of load. Mamta's question is, can we have a where clause while using partitions? Yes, I'll show you this. This is a good question. Let's say here we are querying data. Here we have this. Let's say we query the data called select star from people where you can see qualification equals to 1 and All right. All right. This first question is that the AMP and the AMP1 are available in data hive directory. Yes. So I copied those into my home folder and I loaded it from there. And the reason is when I load some data from HDFS to a table, it will try to move it. And therefore I wanted to copy it. Okay. That's why I copied this the amp and the amp1 into my home folder and then loaded the data from this location. All right. Make sense to you, Biswa? Mumtaz, was I able to answer your question? All right. All right. All right. So, so it'll give an error in yes. Yes, one question is, what if we do not specify the partition column? You have to specify a partition column, otherwise it'll give an error. Okay. Okay. Any other questions? Good. 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 All right. Good. Also, please have a look at what happens in the background. Here, let's go to the file browser and take a look at our table called people. All right. Let's go to file browser, go to warehouse. Okay. Let's go to what was that folder called apps and hive. Under that, you can see there is a warehouse, and under this, there would be my folder called Sandeep. Let me find, there will be some folders with my name. Is it? Oh, it's not there. Oh, I think its name is DC this thing. Yeah, you can see that. All right. So inside this, you can see there are two folders, one for each table, one for NYSE, other for people. Inside people, the interesting part is that whatever partition column you have defined, for each partition, it has created one folder. Okay, for different values, there will be different folders here. And under this, you will find the amp1, the same file which we had loaded, right? And under here, you'll see the other file. Okay, all right, good, good. All right, now so these were the partitions in case of HDFS. Also, the rest of the SQL is very much consistent with the remaining one, and most of the SQL would work as such. So for example, you can have an alter table statement. You could also modify the data type, and you could also rename the columns. And as I told you, that while querying, you might get an error if you modified the table in a way that the data is not fitting into the table. Okay, because at the runtime only, your query will be executing, and this data, the raw data, will get converted into tabular format and presented to you. Okay, you could change columns, okay, from one type to another, as well as you can add more columns, and sometimes you can delete a partition. Okay, when you delete a partition, the data that is lying in that partition might get deleted. Okay, all right. Now there is something called external tables. There is a very thin line difference between the managed tables which we have created so far and the external tables. External tables are great when you are trying to load data which is not yours. If you are trying to load data which is not yours, it means that when you drop the table, the data will not be deleted. Okay, that's the only difference. The only difference between an internal table and external table is when you delete an external table, the data does not get deleted. Okay, it's like a symbolic link and a hard link. If you have a symbolic link, then if you remove the symbolic link, the data does not get deleted. Okay, so similarly here also, when you have external tables, yeah, so in case of external tables, the when you're dropping a table, the data gets deleted. That's the big difference. Also, external table can load data from remote sources. Okay, also the data does not get copied locally. When you run the query, only then the data comes from remote. Okay, here I've tried to create a similar table without any other. So you can create an external table on data stored in S3. For example, you could create an external table called mini wiki stats. Okay, defining the columns and everything. And then you could do a okay, so you can create an external table for S3. Here we are creating a mini wiki stats, and we are saying that our data is partitioned on the date, and row format is delimited by space here. Okay, and lines are delimited by /n, and the location is this. So every time we'll query mini wiki stats, it's going to bring the data from this location. Okay, and in case you're providing this inner parameter of where clause, then only those partitions which are falling into this criteria will get queried. All right. Okay, S3N is the S3 URL. Okay, here when I say S3, here the data is lying in S3. Okay, S3 is Amazon S3 we are talking about. All right, so here the most important thing is, after you have created an external table, okay, so you can add more partitions at later point of time. So we are saying create this table which is partitioned by 3 columns this time. You can see that there are 3 columns now. there will be folders inside folders inside folders. So at the top level, the way we had folders here, the way we had folders in file browser, like only one level, it will be folders under three level. Okay. So when we have partition, the three columns partition, that means there will be three depth of folders there. At the top will be something like year equals to 2016. Inside that it will be month equals to 1, month equals to 2, month equals to 3, and so on. And then will be the date inside every month. Okay, so that's how partitions on multiple columns work. So you can add a partition, remove a partition at any point of time. And also the most important part you should understand is that the individual partition can load data from different location. For example, this partition where year is equals to 2012, month equals to 1, and day equals to 2, the location of the partition is at this place. While for year equals to 2011, month equals to 12, and day equals to 2, the location is this. So one partition coming from HDFS, other coming from S3 is totally okay. S3 is a storage provided by Amazon. Okay, and it's quite popular, and people use it for storing a lot of data. All right, and it's like a very highly available system, with proprietary and software as a service. Okay. So that's an external table. Again, let's do a quick recap. Each table has got a location where the data is loaded. By default, that table is a directory under the location called apps, hive, and warehouse. You can override this location by the table is in a directory. Okay. You can override the location by mentioning location in create table clause. Load data copies the data if it's local. Load data moves data if it is on HDFS for both external and managed. Okay. Dropping managed table creates data at the location. Sorry, when you drop the data, it deletes the data at the location. Dropping an external table does not delete the data at the location. The metadata is stored on the relational database called Hive Metastore. All right. Now, next part, the select statement are more or less like a Postgres or MySQL or MS SQL, and you can do a lot of complex operations in the projections itself. For example, here we are, if you look at this record here, we have, we are saying select upper, salary, and deduction. We are saying convert name to the uppercase, give me salary, give me the federal taxes deductions. As in, deductions is a map and we are accessing federal taxes out of that map. And then we are saying round. Round means one minus deductions and multiplied by salary. Okay. All right. Sometimes you want to finish the aggregation operations on the map side itself, like for example and count and some more average could be done on the map side itself. All right, you can do that by saying hive.map aggregation equals to true. All right, now there is another interesting idea called views. Okay, so while we were creating tables, we were essentially creating a window on top of the data, right? Now, If we create another table, the data will get copied to that destination location and so on, right? And sometimes we do not want that. Sometimes what we want is we want to uncomplicate our query. We have a very big query, and what we want is that we want to break down the query into parts. Or we want to basically do the job like our pig, meaning we define A, we derive B from A, we derive C from A and B, we derive and so on. Okay, so in order to simplify really big queries, we want to break it down into something called views. Okay, so we are saying create view tweets underscore clean as select ID, TS, text, and country from tweets underscore simple left outer join time zone map on time zone equals this. Now what does it mean? Okay, it means that we are creating tweets underscore clean as an alias to this particular table. Okay, we are creating an alias to this particular table. All right, so every time we'll say select star from tweets underscore clean, this whole query is going to get executed. Every time and when we say select star from tweets underscore clean, where one column equals to something else, at that point of time, this query will get one more where clause. Okay, so that's how the views work. And views are a very important concept. All right, a question from Biswa. In the previous slide, what was the data type for deductions in the table? Okay, what was the data type? Deductions was a map. All right. Okay. Sometimes, sometimes your, sometimes the functions provided by Hive may not be sufficient for you. You may want to create custom functions. Okay, just like we try to create custom functions in Pig, we can create custom functions in Hive as well. In those cases, you will have to create something called UDF. Okay, exactly the way we did it in Pig, that we extend a UDF class and implement an execute function or evaluate function. Here also we are doing the same thing. Okay, so the first step is we define a class, okay, which extends UDF, and it must have a function called evaluate. This evaluate function will take the text as the argument and would return the text or any other argument, or any other data type. All right, and once you have done coding your UDF, you can export the jar, and then inside Hive you could simply say add jar and the location of your jar. All right, I'll try to show you this. The good news with HDF, this Hive, is that it's able to register a jar located in HDFS. Okay, if you do not specify HDFS here, it'll think that you're talking about the local file system. So keep that in mind. Let's try to create our own UDF. Okay, Here is our pig UDF. Let me just close everything, close all, and let's go to Hive UDF. You see Hive UDF? Yes. So here you have, all right. Let's say we are saying whenever this function get executed, it'll convert, it'll put asterisks around the lowercase value. Okay. So here we are saying public final class called lower, which extends UDF, and it takes the text as the argument and returns text as the argument. Okay. Now once it is done, we'll say right click and say export. Okay, and jar. Do you see that? Now we move on. All right. So we have exported the data. Let's upload this data to my folder. Okay. I'm using my folder. Okay. So, all right. Okay. Here we go. All right. Okay. So we have got this. Now we can go to Hive and say register HDFS slash slash Hive udf.jar. Sorry, not register, it will be add. We'll have to say add jar. Okay. What does it say? It says that illegal scheme character at index 0. Do I have to put like this? Okay, so it has added my HDFS, my it has added the jar file. Now next thing we want to do is we want to create a temporary function, okay, which is an alias basically. Okay, now let's try to execute this. Okay, let's try to see what happens. Alright, now you can see the asterisks around this string. These asterisks are coming from our function. So our query is successful. Okay, our query is successful. Alright, a question from Medley is view similar to methods? Not really. View is more like a table which has query associated. Well, functions could have anything inside them. All right, now moving on. All right, now sometimes, okay. So right now what is happening is we are loading data using the standard means. Sometimes you want to load data which is complex and not really so primitive in nature. In those cases, you will have to use custom formatters, custom SERDE. We call them SERDE as in serializer, deserializer. They know how to convert some binary data into meaningful tabular format. So these formats are these jar files are called serializer deserializer. The many serializer deserializer available for you as of today, okay, so that you don't have to implement them too much by yourself. Okay, so for example, JSON Survey is quite stable and you can directly use it to load JSON data into a table, meaning you can query a JSON object using Hive. Make sense to you? All right, you can see that first you have to add this particular jar the way we have just added a jar just now. In a similar way, you have to add a jar, and afterwards, while creating a table like this, create external table, and this one, you can define the row format. Okay. All right, so it's essentially saying that my table the way we are going to convert or represent a table will be governed by this particular class. Okay, so that's one thing. Next is the sorting and distribution. All right, this is very interesting aspect of any system. Imagine how would you do sorting using MapReduce? Okay, our data was not anyway sorted, the word count one, although it looked like sorted, but each individual partitions of the output, meaning part 1, part 2, part 3, they were individually ordered, but the overall data is not was not ordered. Okay, all right, let me go back what I'm saying. So if you recollect our discussion on partition, so we had created second partition whereby there were two partitions, one for less than j and other for greater than j. Okay, so in there, only in that case, if you just concatenate the two parts, part 1 and part 2, you will get the ordered result. Okay, but if you do the usual word count without a custom partitioner and with having multiple reducers, okay, and you try to concatenate the two reducers, the output will not be ordered. Okay, it will not be strictly ordered. All right, so similar problems also surfaced with Hive. Okay, initially what they did was they implemented ordering of the record based on based on a particular column, but that was only using single reducer. Okay, they did not delegate that work to multiple reducers, because the moment you bring in multiple reducers, the order by would not work, because the resultant would have multiple partitions, sorry, multiple, what do you call, uh, multiple reducers, and therefore multiple files in HDFS, and they may be having overlapping ranges. Okay, so order by X guarantees global ordering. The only downside is it will pass through all the data through a single reducer. This is basically unacceptable when the data set increases. So you end up sorting the entire file of an output, which is very inefficient. That is why Hadoop guys came up with this idea called sort by X. Okay, so what it does is it basically splits the overall process into n reducers. Okay, while 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 the resultant may not be sorted, you will have n sorted outputs. Individual parts may be sorted. Individual parts are sorted, but not overall partition. Not overall data set is sorted if you use sorted. So that's why Hive came up with another idea called distribute by X, which is equivalent to saying define a partitioner on a column so that define partitioners such that there is no overlapping ranges and one data set is completely out of the range of the second one, so that they individually can order the data and then just concatenate the back to back, and you get the, if you concatenate the two parts back to back, you get the resultant. So to get the proper ordering in a big data, you have to do few things. First, have multiple reducers. First have multiple reducers. Second, divide the work amongst reducers, or divide the keys amongst the reducers such that keys are non-overlapping. Okay, so it should not happen that reducer 1 got A and let's say A and B, and reducer 2 got A1 or AA and BB. Okay, in this case you can see that these are overlapping ranges. If you try to concatenate reducer 1 and reducer two's output, what would happen is we'll get A, B, AA, BB. Okay, which means this will again have to be sorted so that we get a result like A, AA, B, and BB. So what I'm trying to say is, whenever you have to sort big data, you have to have this kind of result instead of so this kind of result is only possible when reducer 1 gets A and AA and reducer 2 gets B and BB. Okay, and if you have this kind of circumstances, only then we will get the reducer 1 plus reducer two's output. Okay, now coming back to it coming back to it how will you make it possible? How would you ensure that reducer 1 gets AA and A while reducer 2 gets B and BB? By the way of partitioning. And in case of Hive, you do the same thing using distribute by. Partitioning and sort by is saying that have more than one reducer. Which means if you combine distribute by and sort by, then you get the desired output. And that's where the cluster by X comes into play. Cluster by X is equivalent of distribute by and sort by. Okay, it ensures each of the n reducers get non-overlapping ranges and then sort those ranges by multiple reducers. This gives you global ordering. This is same as combining distributed by as well as sort by. You end up with n or more sorted file with non-overlapping ranges, which means they can simply be concatenated and you will get the desired result. Okay, or you can say cluster by is basically a more scalable version of order by. All right, the example is you can say select column 1 comma column 2 from table, distribute by column 1, sort by column 1 ascending and column 2 descending. Okay, or if you want to have uh, say select, you can also replace distribute by and sort by with cluster by and saying select column 1 column 2 from table cluster by column 1, and you will get the desired result. All right, So that is how sorting is done. Although sorting was supposed to be very simple aspect, but it can go to quite complex. Okay, there is another cluster by in Hive. It is another cluster by. If you want to convert the table into the multiple buckets at the time of loading the data itself, then you can use cluster by clause while defining the table. So while you're loading the data, at the time itself, it will convert it into multiple buckets, and this would help in running reducers on individual buckets. All right, so that's what is called as. All right, let me give you a quick demo. Okay. Yes, one's question is view doesn't sort anything. No, it doesn't. Basically, view is nothing but a shorthand for a query. Big query, a little shorthand for the query. Okay. Okay. View doesn't store anything. Yes, it doesn't. It doesn't store anything. Okay. And next question from Yashwant was, is this similar to parallel in pig? Do you mean sort by? Yeah, sort by is similar to parallel in pig. That's very right. Great, great. Any questions at this point? All right. So let's try to do a quick demo. Okay, let's try to do a quick demo, and I would rather. Okay, all right. Let me try to. Okay, first of all, let's just first prepare the data. Okay, let's first prepare the data. The data can be either prepared by downloading this file, or we have already downloaded it into our HDFS. So here you can see the data folder. Not here, not data. I'll delete this data folder. And here, if you go to data, there will be one folder with the name ML, this one. So you can see there are so many files in this folder. Let's just copy this. Okay, let me just copy it for time being. Afterwards I'll delete it. Okay, so which file I'm interested in, let's have a look. So first we will download this, which we have already downloaded, and put it into the data folder, and also unzipped it. Okay, and if you put exclamation inside Hive, you can execute local command. That's what we are doing. We are saying exclamation. That means whatever comes after exclamation is being executed as a command. Okay, so we can say load data from this place, overwrite into this table. Okay, so let's try to first copy this data to one folder. This is the file which we are interested in. All right, u.data. So let's just copy the u.data. Do you see u.data somewhere? It's inside it. This is the one which we are interested in. Okay, so I'm copying this to my home folder. Okay, all right. Now we go back to Hive. Okay, we go back to Hive. and create this table. Let's create this table. Here we say, all right. So let me just check. Yes. All right. Now we don't have to say any of this. We could actually just put our username called Sandeep Giri 8332. It did not copy. Oh, we don't have to say local. All right. It says that no matching, no files matching path this. Did I make a mistake somewhere? It says home, or not home. We have to say user. Okay. So it has loaded the data. Now let's have a look at select star from u underscore data. Okay. All right. Now we can start doing all kinds of magic. Now what kind of data are we talking right now? This is basically movie data. Lots of people have rated movies with at various period of time, and this is that data. Now let's say what I want to do is group by user ID, okay? And I want to say that for each user ID, what is the average rating? Okay. All right. So we have computed average rating of movie given by each user. Okay. If you want to if you want to find out the average movie rating, then we can also do things like select movie ID, average of this, and so on. Okay. So yeah. So you can see that for each movie we have done this. Similarly, what you can do is for rest of the folders there in that file, for rest of the folders you can load those other files as well. Like for example, if you go into this place, you can load these as well into Hive and then join that with u.data. For example, here, what was that movie item? Okay, u.item. You can see that Toy Story, Golden Eyes, Four Room, and so on. These are the movies, name, URL, date of release, and so on. Okay. The description of this file is available in u.info. u.info. Okay. 943 users, 1682 items, and so on. Okay. Not in this. There is something item.details. Okay. All right. Yeah, here's the detail about all the movies. Okay. All right. So we are able to successfully execute our Hive queries and also give you a quick example of some movie ratings data. All right. So that was our discussion on Hive. All right. As an assignment to all of you, find out for each movie how many people have voted it. Also, find out the ratings, average rating of the movies which have been rated by more than 30 people. Okay? Because uh, let's remove all those movies which have been only rated by less than 30 people, okay, and compute the average rating of the remaining movies. All right, so that's an assignment for to all of you. Is the assignment clear to you? Vishwa is saying, why is it written as stored as text file? Because you can store it into RC file as well as sequence file. RC file is equivalent of the CS sequence file. Okay, there are many formats while storing into Hive, and one of them is text file, and other is RC file. There's some more formats which Hive allows. All right, Vishwa. All right, great. All right, so that was our discussion on Hive. All right, so I would like to give a quick brief introduction of NoSQL, and so that we are all on the we have something to think about over the week other than finishing assignments. Okay, try to finish your assignment over the week. Now we have 15 minutes. We'll just go over the the theoretical aspect of NoSQL, general theoretical aspect. Okay, Midley's question is where the data is stored for this assignment. Data is stored in slash data, okay, slash data and ml 100k. All right. Okay, so let's start with our general discussion on NoSQL. Is that okay? Very high level. All right. Nobody is saying hi. Yes. All right. So Yashwant is saying, would we be covering MongoDB? No, not in this. Okay. Abhay is saying number two assignment. You mean this one here? Okay. Yeah. So, all right. Let me explain again. This is a very important exercise, and I'll say. So, when you compute the average rating, how do you compute average rating of each movie? You group by the movie ID and then compute average. Now, what is wrong with the normal average? If you are purchasing things from e-commerce portal, you'll find that the average rating of the products which have been rated by one or two users is really high. Okay, so my whenever I'm buying something online, I first order the data by their ratings. Now, out of these ratings, you will find that the top one, the one which come at the top are something voted by 3 4 people or 5 people. Now these are generally the biased user rating. These are generally what we call in statistics is volunteer bias. Okay, volunteer bias as in they especially volunteered for rating the movie, or they specifically volunteered for rating a particular product. Okay, it's a volunteer bias, because if something is being highly voted and by voted by 1 or 2 persons, generally we do not trust that. And that's what we want to do as part of this query. You're given a lot of movie ratings, you just want to remove all those movies which have been rated by less than 30 people. Okay, that's what we have to remove as part of the second assignment. Is that clear now, Yashwant? All right, now let's discuss briefly about NoSQL. We have 10 minutes. If you have some other question, I can answer those questions as well. Uh, Okay, right. So this is a very important concept and we need to understand this. All right. Okay, so what is NoSQL? In case you don't know SQL, you can put it in the resume that you are expert at NoSQL. Is that what it is? All right. So question from Yashwant is that are HBase and Cassandra similar? They are very similar in behavior. Okay, and HBase is considered kind of better than Cassandra these days. Okay, all right, all right. So this is how you have to write a CV. Okay, you can leverage the SQL part. All right. So before we jump into the NoSQL part, let's understand few keywords. Although we must have already explained these keywords, but again, so if somebody was having a single horse cart, and they wanted to carry more load, okay, they could do multiple things. One, instead of horse, or instead of a weak horse, they could buy a very strong horse, or afterwards removing the strong horse and they could put elephant in the cart. Okay, that is vertical scaling up. Now this is very limited because an elephant is how many horsepower? Anybody can anybody tell? On an average, if you compute what will be the difference between a horse and an elephant in terms of horsepower? Yeah, guess how much would it be? Biswa says an elephant would be 8 horsepowers. Okay, okay. Midley is 4. All right. Yeah. Anybody else? Yashwant says 40. Okay. And okay. Mamta says it'll be an elephant would be 4 to 6 horsepower. Interesting. Interesting. So I did some Google search here and there, and it turns out that an elephant is around 2 horsepowers or little above 2 horsepowers. Okay, this was something interesting which he found. Abhay says 10 horsepower. Okay, I also was, my estimation was actually around 5 horsepowers, but when I did a little bit research, I found that it's hardly 2 or 3 horsepower. Okay, or maybe my research may be wrong. Okay, so let's for argument's sake, let's say that an elephant is 5 horsepower. An elephant is equal to 5 horsepower. Now, after those 5 horsepower, then what? If you cannot, if your requirement is say 5.5 horsepower, then an elephant won't suffice. Then what will you do in that case? Will you wait for some other animal to come around? Maybe wait for dinosaurs to come around, and and then so and then think about something, or wait till the load requirement goes beyond 5.5, and think about something till that point of time. Okay, but so that's an interesting aspect, and that's what we did in IT industry as well. When we could not manage load by using a single computer, by a normal computer, we started buying really high-end computers, supercomputers, this, that, and we started buying all of that. Okay, but in reality, that does not solve problem. So this vertical scaling or scaling up hardly solves any problem. It just solves the problem for some time, but afterwards the load hits you again and you can't go anywhere at that point of time. Okay, you can't wait for a bigger computer to be purchased, and that's where the horizontal scaling comes into play. So the clever thing to do, even in the war strategy and everywhere, instead of putting uh, instead of having elephant carry the cart, they started putting horses into the cart. More horses. Okay, the way we have dual core, and so on. Similarly, they also started putting more horses into single cart, and that's what we call horizontal scaling. Now, after these distributed computing, the whole scaling out or horizontal scaling has been taken to another level. As of now, every machine has got multiple computers, and all those computers are connected together to do the job. Okay, so you can think of a single big cart made up of many small cards, and every all of this is being very well distributing the load amongst all the horses. Okay, so that is the role of horizontal scaling. In horizontal scaling, there are many things that come into play. If you think about what if this horse died. Okay, one horse died, you could buy just one horse and be happy. But in case elephant dies, the big elephant, then the whole work is gone. All right. So effectively, vertical scaling is no longer a solution to handle data. The only way forward is either horizontal scaling or scaling out. All right. Let me tell you this interesting story. Okay. This interesting story is actually yes. One's further interesting point is that an elephant weighs some 40 times more than the horse. Yes. So the effectiveness of an elephant is again gone down because it weighs higher, that therefore it doesn't run that fast. Okay, now coming back to it, so this story is about lot of startups which failed, a lot of companies which failed to cope up with the load when internet era started. Okay, when in 2005 or 2003, 4, 5, 6, that time I remember many company burnt out. Reason being, they could not cope up with the load. And the excuse was that, the we did not want to burn too much money into hardware to solve our problem. But the truth was, the technology could not cope up with the load. And that's the story here. So you launch initially and you're very happy. And I have gone through this phase at DE Shaw. So we had this humongous load coming to our Postgres, and the way we were managing was exactly in the same way. Initially, we were pretty happy that okay, this is the software. We have done the best relational diagrams and we have done the best coding, and we launched it. We moved from our workstation to some demilitarized zone. We call them DMZ. We launched the servers and we were happy that this is great, and the champagne and whatnot. Next is the service became little popular. There were too many reads hitting the database, and so as a good engineer, we quickly put the memcached. Memcached is a caching solution, and we put that in place quickly. Now we were pretty happy for a couple of days. Reads were okay. We were pretty happy for a few days, but then our DBA was not happy. He said that even though you have put the cache, you have hurt the consistency. Hurting the consistency, what does it mean? When you put a caching solution, what happens is when somebody changes the data, it takes some time for the cache to be updated. Therefore, till the change has reached the cache is serving the old data, the stale data. Effectively, the moment you put cache into a system, your system is no longer consistent. Okay, your system is no longer consistent. All right. All right, let's continue this discussion on the next week. In the meantime, try to finish the all the assignments, whatever we have given you so far. And Biswa, I will go through your assignment maybe today or tomorrow. All right. Have a good day. Bye bye. Once you finish your subjective assignment, drop me an email. All right, and I'll take a look. All right. Have a good day. Thank you, Mamta. Thank you, Biswa. Thank you, Midli. And thank you, Mahesh. Thank you, Abhay. Thank you, Yashwant. Have a great day. Bye bye. See you next week.